What's up? My name is Cody Engel. I'm a staff software engineer. I upload videos to YouTube weekly. I want to answer the question, what is dependency injection and should you use it? Before getting into what dependency injection is, let's first talk about what problems dependency injection solves. One of those things is if you don't use dependency injection, your code ends up being fairly inflexible because it's relying on concrete versions of the code that you want to execute. It has to create new instances of those objects. It's unable to sub those out at runtime. And so through using dependency injection, you create a much more flexible application because you can replace those anytime that you want. So dependency injection allows applications and classes to define their dependencies through different configurations. So you can have a production configuration, which is what your end users would be relying on while using your application. You can also have a staging version, which could be very similar to production, except maybe it'll have some debugging information that makes development a little bit quicker. You can also have one for integration testing that allows you to provide sample data without having to hit actual API endpoints. And one that you use fairly commonly with dependency injection is being able to provide your class that is depending on objects, being able to provide it with mock objects. And by having mock objects, you can do specific verifications, and instead of having to rely on what those dependencies do, you can just say that that dependency will do a specific thing, such as throw an error, so you can test error cases with your code, or just return the success state that you would be expecting to ensure that if everything goes well, that your implementing class actually works correctly. All right, so now that we've talked about what dependency injection solves, let's talk about what it is. So dependency injection implements the inversion of control principle via composition. The inversion of control principle, it's this idea that the class relying on the code isn't the one that's actually supplying it. It should be the inverse of that. So dependency injection also allows you to do polymorphism via composition as well as with delegation. And so the way that you might achieve that is by having a set of interfaces within your class, and that class can delegate how you actually execute code within those different interface functions via a dependency that you've injected. All right, so with dependency injection, there are 4 rules that you want to keep in mind. So the first one is you need to have at least one or more service objects. And what these service objects represent are dependencies that are going to be used by some other object. So you can think of that as a service object being a car, and it may be a diesel car, a hybrid car, gasoline car, or electric car. The next part involves client objects, and so those client objects, they are going to depend on one or more service objects. And so the idea of a client object is similar to a driver of a vehicle. They're going to drive a car the same way regardless if it's a diesel, electric, or gasoline car. One thing to keep in mind with this is that a client could be a service object for a different client. So they're not mutually exclusive things. In a dependency graph, you'll have the client object, and then that client object will rely on service objects. But the service objects themselves may be client objects to other service objects further up the dependency graph. So the next one to think about are interfaces. And so with these interfaces, they define how the client object is going to make use of the service objects. So going back to that car example, think of it as, is this a manual transmission car or an automatic car? And how that may change how you actually go about using the dependency itself. And then the last one with dependency injection is the injector itself. And so this is responsible for setting up those dependencies. So it'll construct the services for you, and then it will ensure that the client receives those services so it can make use of them. So a couple of examples you can think of would be if you're going to a car rental agency to get a car, you may not get the car that you were looking for. They will just supply a car to you that kind of meets the requirements that you were looking for. So a compact or regular size car or SUV or truck. All right, so now that we've talked about the different rules with dependency injection, it's time to talk about the different types of dependency injection. And so with that, there are kind of three main types that you'll encounter. The first one and most popular one would be constructor injection. And what the idea of constructor injection is when you're creating the client object, you're supplying that client object all of its dependencies through the constructor. So before the client object can be created, it needs to have all of those service objects supplied to it. All right, so the next method of dependency injection comes in the form of setter injection. And the idea of that is you can create your client ahead of time and then supply the dependencies through a set of different setters where you will provide the services through setter functions. So it's not required to create the object, but before that object can execute any of the code it's dependent on, you would have to supply those dependencies through setter functions. This can be a little bit more difficult to do than, say, constructor injection, because setter injection, you'll tend to want to do some sanity checks to ensure that the dependency that you expect to be there has already been set by the outside code. And if it hasn't been set, you'll usually want to fall back to something else, or perhaps just throw an exception, but you usually have to have a little bit more error checking in place with setter injection. The last type of dependency injection that I want to talk about is with interface injection. And interface injection essentially is where you will define an interface up front. That interface, it can have many different functions. One of the required functions will be one that allows you to set the dependencies. So it takes what setter injection has, but then it also allows you to attach other functions into that interface. All right, so the last type of dependency injection is interface injection. And the way interface injection works is the client will implement the interface itself. That interface needs to have a set function that says, it'll say set, and then it'll take the parameter of the interface itself, and then you can supply a concrete implementation of that interface. From there, you can have the client code just proxy requests to the different interface functions to the class being supplied with the interface. With more modern languages, such as Kotlin, you can actually achieve interface injection through something called class delegation, where you just create an interface and then you create that concrete version of the interface. Then you can say that your client code implements the interface, and then in Kotlin it would be a by keyword with the actual concrete version of that. And so you'll see different flavors of interface injection. In much older languages, you'll have to do the setters yourself, whereas with more modern languages, it'll tend to do that setup for you in a much easier way. All right, so at this point, you might be wondering, when would we talk about dependency injection, like the libraries, the frameworks? So like Spring, Juice, Dagger. And I think it's important to call out that dependency injection can be done without a library, can be done without a framework. Really, when you supply arguments to an object through constructors, you're essentially doing dependency injection already. And so while those libraries and frameworks do exist, they do end up freeing you from various boilerplate and having to wire up dependencies yourself. It's important to acknowledge that you don't need the library. All right, so let's talk about some of the advantages of using dependency injection. So one of them is the client has the flexibility to be configured. Since you're supplying all the dependencies to the client itself, and it doesn't have to worry about the inner workings of that, you have much more flexibility in terms of being able to change out the configuration on the fly. With dependency injection, you also don't have to worry about the burden of refactoring with legacy code. If you need to make something more unit testable, you can take that legacy code and you can extract out different classes into their own separate concrete implementations, and from there you can end up writing better tests and also have the class a bit more flexible. So when you're working with legacy systems, you can actually use dependency injection to your advantage by extracting out a lot of those larger classes into smaller, more manageable, more testable ones. Your clients also become a bit easier to test in isolation, because since you're supplying all of their dependencies either through constructor, setter, and interface, you're able to take those dependencies and supply mock versions of them, or versions that are just specifically there for tests. And with that, you're able to really set them up for different error scenarios, different success scenarios, and you can get a lot more coverage with your unit tests. And another thing that ends up happening is if you get a really hard to debug client error and you can't reproduce that yourself, oftentimes you can supply a mock version. You can see kind of how they're getting into that situation and then set up the mock so it goes through those same steps, reproduce that error, and then go in and actually fix the bug itself. And then the last advantage that I want to talk about is also the one that I think is the most important, is dependency injection allows work to be split up among many developers without having to worry about them stepping on each other's toes. The way that this works is you can have one developer working on the client code that's going to rely on different services, and those services can be worked on in parallel by other developers. And so the developer working on the client code, they just have to know what the interface is going to do and roughly how it's going to work, but they don't have to worry about actually writing the internals of that. And likewise, the developers working on the service classes, they don't have to worry about how the client is going to consume it. They just have to worry about this is how the service itself needs to work. And so you can end up getting a lot more done. It does require a bit more coordination among the developers, but if done correctly, you can get a lot more work done. Dependency injection isn't without its own disadvantages, though. One of those disadvantages with dependency injection is that it can actually encourage you to have a dependency on a specific dependency injection framework. So if you're dependent on a very opinionated framework, it may be much harder for you to separate your code from that dependency injection framework in the future. You can get around this by using more standard libraries. So one example would be if you're using Java, there's a inject annotation, and that inject annotation is used by many different dependency injection frameworks. And so it allows you to swap out the framework without really having to do too much more rework. On the other hand, though, if you are using a really opinionated framework, you may not be able to achieve the same thing. So just be careful when you're picking out the framework. Make sure that it will be flexible in the future, that if you do decide to use a different framework, it should be easy to swap it out. Another disadvantage with dependency injection is that it requires more upfront development work. So oftentimes, if I'm just going to work on a general proof of concept application, or I'm just working on something for fun on the weekend, I may not use dependency injection. And the reason why is it just takes a bit more time to set up. If I'm writing a production-ready application or writing one professionally at work, I will use dependency injection because the upfront work is worth it. But for those smaller projects, ones that are shorter lived, it may not be worth it to invest the time in doing dependency injection. All right, and so with that, should you use dependency injection? And if you're asking me, I would say absolutely you should. There are so many benefits to it. Through using dependency injection in my professional projects, it's made my life so much easier. Oftentimes, when I'm working on a specific class, I want to have a good amount of unit test coverage for that, because I want to cover all of the different states that the class is supposed to work around while I was writing that code. And so without dependency injection, you have to understand how the inner workings of that class work, and then you have to kind of set up the test itself to do that. So let's say you're working with a class that makes an API call, If you're not using dependency injection, you would have to set that API call up to return a success case and an error case. And oftentimes to do that, you may have to set up your server in a situation where if I request user ID 1, that will return a success with the user ID information. And then maybe if I select user ID 404 from the API, it'll return an error with some error body. On the flip side, through using dependency injection, I don't have to worry about the API at all. All I have to do is my calling code. I just have to mock out what it does to say, when I make this request, it should give me an error, and vice versa. When I make this request, it should give me a success response. So you can write classes much quicker, test them a lot faster, and your code ends up being a bit more rigid in that sense, where you know what works, you have a good idea of what doesn't work, and if you do encounter errors in the future, it's easier to recreate those error situations. Another thing that I like with dependency injection is when you have to swap out implementations. If you have a bunch of code that isn't relying on dependency injection, swapping out that code requires, either just commenting out the code entirely, deleting that code. Whereas with dependency injection, you can keep the existing code in place, write a new concrete implementation for, say, an interface that you're working on. And then once that's ready to go, you can swap out the dependency through the injector with the new version. And then ideally everything just should work. And then another thing that's really nice with dependency injection is kind of going back to just that idea, you can split up work among many developers. Oftentimes we're not working on a single feature as one person. We're working on that feature with multiple developers involved. And so without dependency injection, you end up having, say, one class that 2 or 3 developers are working on. At that point, you're going to get a lot of merge conflicts. You're going to spend quite a bit of time resolving those issues. Whereas if you use dependency injection, again, you can just split up the work into different classes, into different bodies of work, and then essentially just glue those pieces together, where you have a client that has the injector that is supplying the client services, and then everything theoretically just works. All right, so thank you so much for watching. This video idea, it actually came out of grabbing lunch with a former colleague. We were just talking about work in general, and then the idea of dependency injection came up, and he mentioned, you've been making some YouTube videos. That's probably a video you could make pretty quickly. And so I ended up just making the video, as you can see. And so if you would want me to answer other questions around software engineering that kind of start with like what is, let me know in the comments section. If I can answer it in a somewhat intelligent manner, I'll make a video as soon as I can. Otherwise, be sure to like this video if you enjoyed it, dislike it if you didn't like it. If you want to stay up to date with the videos that I'm uploading, be sure to subscribe. And if you want to be the first one to watch my new videos, click the bell icon. YouTube should send you push notifications. And otherwise, again, thank you for watching, and I'll catch you in the next one. All right, so I was going through the process of writing the script for this video. I came across another way of explaining dependency injection, and it's from, the person who was attributed for this was John Munch. I don't know if I'm pronouncing his last name correctly, but it's called Dependency Injection for 5-year-olds. And what John said was, when you go and get things out of the fridge for yourself, you can cause problems. You might leave the door open, you might get something mom or dad doesn't want you to have. You might even be looking for something we don't even have, or maybe it's expired. What you should be doing is stating a need. So, I need something to drink with lunch. And then we will make sure that you have what you need when you sit down. And so that's kind of really the idea of dependency injection is you say what you need, but you don't worry about actually going and getting it. And that's kind of the role of, again, that injector, is that it will see what you need, and then it'll ensure that you have it when you need it.